Okay, so this is my homework. The first problem is kind of discussing the process that we're going to use for solving the next two. And it's just going through the cross and then the results, and then how to do the chi-square analysis, and then determine the degrees of freedom. It goes through all of that. And then problem 2, okay, so it says in corn, purple kernels are dominant over yellow kernels, and full kernels are dominant over shrunken kernels. A corn plant with purple and full kernels is crossed with a plant with yellow and shrunken kernels, and the following progeny are obtained. So it says that we have 112 purple full, 103 purple shrunken, 91 yellow full, and 94 yellow shrunken. And it's asking what are the most likely genotypes of the parents and the progeny, and then test your genetic hypothesis with a chi-square test. And we're going to do that in 3 steps. And so the first question is asking what information is required to solve this problem. In order to solve this problem and to be able to do the chi-square analysis, we have to figure out the genotypes of the parents, the progeny, and then do a chi-square test for it. And then part 2, it's asking what information is provided here to solve this problem. Well, in the beginning, it tells us what is dominant over what, that purple is dominant over yellow and full are dominant over shrunken. And we also know the phenotypes with the parents, because it's saying that a corn plant with purple and full kernels is crossed with a plant with yellow and shrunken kernels. And then it tells us the phenotypes of the progeny and then the numbers associated with them. And then for part 3, it's wanting to analyze the color and the shape traits separately. So when we do that, we're just going to do a cross between the purple and the yellow. And if you were to add up the results right here, so those are both purple, so we'd add up the 112 with the 103, and we end up with 215 purple progeny. And then we would add up the yellow, full, and shrunken, and we'd end up getting 185 yellow progeny. Then in the second cross, we'll cross the seed shape. So then if you add up the fulls, you end up getting 203 full progeny and 197 shrunken. And now we know that because some of the progeny are yellow, which is recessive, that means that the purple parent has to be heterozygous. And then the yellow is homozygous recessive. So the first one is uppercase P, lowercase p, and the second one is lowercase p. And then it's the same thing for the kernel shape. So one parent has to be heterozygous dominant, because that one parent that we cross, one is purple and it has full, so it has to have at least one dominant allele. So one parent is dominant, which is uppercase F, lowercase f, and then the other one is shrunken, so it has to be homozygous recessive, which is lowercase f, lowercase f. And then it's wanting us to combine the 2 traits, and when you combine them, you have a purple full parent, which is uppercase P, uppercase F, lowercase f, and then a yellow shrunken parent, which is lowercase p, lowercase f, lowercase f. And then for the next part, it's wanting our expectation in the chi-square analysis, which means the degrees of freedom. And with these progenies, we expect to see 1/4 purple full, 1/4 purple shrunken, 1/4 yellow full, and 1/4 yellow shrunken. And so therefore we should see 100 of each with a total of 400 progeny. And then right here is my chi-square analysis. So there's the basic equation for it. It's the observed minus the expected squared divided by the expected. And so to do this, we have our 112, those are our purple full progeny, minus our expected, which is 100, squared, and then divided by 100. And so we're going to do that for every one and add them together. And then just doing it step by step, we end up getting 12 squared divided by 100, 3 squared divided by 100, 9 squared divided by 100, and 6 squared divided by 100. And once you square those and then divide them by 100, you get 1.44, 0.09, 0.81, and 0.36. And we add those up to get a total of 2.7. And so, and to figure out our degrees of freedom, we have 4 expected phenotypes, so that is equal to n. And n minus 1 is equal to the degrees of freedom, so 4 minus 1 equals 3, and that's how many degrees of freedom we have. And then moving on to problem 3. So Joanna has short fingers, which is brachydactyly. She has 2 older brothers who are identical twins, both have short fingers. Joanna's 2 younger sisters have normal fingers. Joanna's mother has normal fingers, and her father has short fingers. Joanna's paternal grandmother, her father's mother, has short fingers. Her paternal grandfather, her father's father, who is now deceased, had normal fingers. Both of Joanna's maternal grandparents, her mother's parents, have normal fingers. Joanna marries Tom, who has normal fingers, and they adopt a son named Bill, who has normal fingers. Bill's biological parents both have normal fingers. After adopting Bill, Joanna and Tom produced 2 children, an older daughter with short fingers and a younger son with normal fingers. And so I guess for part 1, we were supposed to show the pedigree for this family, and that was provided below. So here's her paternal grandparents. There's her paternal grandmother, and then the deceased grandfather, and then her mother and her normal grandparents, and then her identical twin brothers. And then here is Joanna. She is affected. She has short fingers, and she marries Bill, who doesn't. He has normal fingers. And then here is their affected daughter and their unaffected son, and then their adopted son. And so it's asking what's the most likely mode of inheritance for short fingers in this family. And the most likely mode would be dominant, because it doesn't skip generations and it doesn't distinguish between males or females, so it is dominant, autosomal dominant. And so if Joanna and Tom have another biological child, what is the probability, based on your answer to part B, that this child will have short fingers? Well, Tom has normal fingers, and because short fingers are dominant, he's homozygous recessive for that trait, so he doesn't have it and he isn't able to pass it on. And Joanna has short fingers, which are dominant, and because her parents are heterozygous dominant, because her parents are affected and then non-affected, her dad is affected, her mom isn't, she's heterozygous dominant for it. Oops. And so, well, as I said, she's heterozygous dominant. And then, so if you were to do a cross between them, you would end up with half heterozygous dominant and half homozygous recessive. So the probability of their next child having short fingers is 50%, or 1/2. And that is all.